Welcome to adding and subtracting rational expressions with common denominators. Okay, so thinking about in the past, we could only add fractions that had similar common denominators. Remember this 9 here? Both up here, so we keep the 9 on the bottom. Then you just add what's on top of 4 and 5, giving you 9, and that would just reduce to 1. Okay, so the steps are to add or subtract the numerators, place over the common denominator, and then simplify if possible. And we followed these steps right here. So this was step 1, and this was step 2, and this was step 3. Now let's actually apply this to a rational expression with variables, like in example 1. So let's have our fraction bar, and on top we have 5y plus 9y. Adding those together would give you 14y, and then it says to place over the common denominator, and then note if you can simplify if possible. So for this purpose you can think of 14 as the product of 2 times 14, and then have your y over 2 times x. Which you can say those two 2's cancel out, leaving you with just 14y over x as the solution. Looking at number 2, our first step would be to bring everything together with addition. So what I like to do is to just bring everything together with an addition when you have two different terms. So for this on top, you're going to have 4y plus 8 plus 8y plus 4. And let's place that all under our common denominator. Now let's note we can combine only like terms, so everything that has a y will be circled in blue, and everything that is not will have an arrow attached to it. So we're going to be left with our common denominator on the bottom. That's important. I like to do that first, so always write it first. So we have 4y and 8y will combine to give you 12y. Okay, and we have 8 and 4 give you 12. And if you look, I believe that is as far as you can take it, so this rational expression is simplified already. Looking at number 3, let's write everything together. 4 plus 7y minus 3 all over our combinator of r plus 4. So everything that isn't common I'm going to circle, so I have this 4 and this negative 3. So combining those on bottom, remember r plus 4 is our common denominator. So on top, 4 minus 3 is 1 plus 7y. And that cannot be reduced any further, so that is the solution. Okay. Now we're dealing with subtraction, so we have 8y over 7 minus y minus the quantity 7y over 7 minus y. So for subtraction, I like to write the first term, the first part, minus, and then open up parentheses followed by everything that is followed by that minus. In this case, just minus the quantity 7y all over 7 minus y as our common denominator. So we have, when we distribute this negative across, in this case it's really simple because there's nothing continuing this term, so we just have 8y minus 7y over our quantity 7 minus y. So now if we simplify these two quantities, 8y and 7y, we're left with just positive 1y or y over 7 minus y as our solution. And we have one more example for this problem set. So let's start off by first writing our first numerator, negative 8p minus 7 minus, and now I like to open up parentheses and write everything that follows. So 2p plus 7, close parentheses, and then please don't forget to write the common denominator. Okay, now what you want to do is take this negative, and and multiply it across everything that appears in the parentheses. So we're going to rewrite everything that we have except the parentheses of 8p minus 7 with our common denominator of 6p. Now in red, I will write everything distributed, so we have negative, and when it's just that negative, it's just going to change the signs inside, so we have negative 2p minus 7, because that's what you distribute across. Now combining like terms, everything that has a p will be boxed in a black square. So we have the negative 8p and the negative 2p, and notice that I will put an arrow above everything that is common to each other. So we have our fraction with 6p our common denominator on the bottom. So combining negative 8p and 2p will give you negative 10p, and then negative 7 minus 7 gives you negative 14. Now it's important to note that this can be factored even further, because if you note, a 2 can be brought out of this first term. So we have 2 times, and then we have negative 10p divided by 2 is just negative 5p. Okay, and we see that negative 14 divided by 2 gives you a negative 7 on top and on bottom. We can pull a 2 out there, and 6p divided by 2 leaves you with 3p. Notice those two 2's can cancel out, leaving you with the quantity negative 5p minus 7 over 3p as the denominator, and that is the solution to that problem.